So if we have a look then at the next part there, we're looking at functions, cubic functions that are often written a little bit differently, okay? So ax cubed plus bx squared plus cx plus d. I mean, we could expand these ones here to look like that, but only those that can be written in this form will look like this here, okay? Ones like this typically will look like the other type, okay, where you've got a local minimum and a local maximum, either a positive cubic or a negative cubic, okay? Now, there may be 1, 2, or 3 x-intercepts, okay? And if a is greater than 0, so we've got a positive cubic. If a is less than 0, then we've got a negative cubic, okay? All right, so in order to find the x-intercepts, then we factorize and solve by letting y equal 0 and so on. Now let's have a look at example 2. This one here is already in factored form, so it'll be pretty quick to work through. All right. Now there are 3 intercepts. We know that it's going to look like this. If we were to expand it, let's just have a look at what we've got here. There's no negative number at the front, and each of these x values are positive. That means we must have a positive cubic, okay, which means it will look like that. Now y-intercept, when x equals 0, I have negative 1 times 2 times 1, because x is 0 in each of these brackets. And when we multiply that out, we end up with negative 2. Okay, so that's our y-intercept. Our x-intercepts are really easy to see when it's in this form, because when y equals 0 and we apply the null factor law, then we're left with x equals negative 1, positive 1, because 1 minus 1 is 0, or x equals negative 2, or x equals negative 1. Okay, so our x-intercepts from here by using the null factor law will be x equals 1, negative 2, and negative 1, because either x minus 1 is 0, or x plus 2 is 0, or x plus 1 is 0, giving us these answers. Okay, so then we can go ahead and we have mark our axes in 1. So we have x-intercepts at 1, negative 2, and negative 1. We know that it's shaped like this, which means that it's going to have to go up through there, curve over, down, pass through negative 2, and then go up again through 1. Okay, and that is our sketch. Now, at this stage, we don't need to find these turning points. That's not going to be straightforward, and we'll have to leave that till we can work through the calculus unit. Next, we're going to sketch the graph of this one here. Okay, now if we have a look, our leading term is positive 3x cubed. So it is a positive cubic, which means it's going to be shaped like that. Our y-intercept, when x equals 0, we're left with negative 6. Our x-intercepts, by letting y equal 0, we end up with x cubed plus 2x squared minus 5x minus 6 equals 0. Now how do we solve that? We have to go back to the previous work we did, factorize and solve. Okay, so what we're going to do is have a look. We need to find one linear factor, and by doing that, we can see that we'll end up with, by trying x equals -1, that will actually work because -1 cubed is -1. This will become +2, which is +1. This will become +5, which is 6 minus 6 is 0. Okay, that equals 0, which means that x plus 1 is a factor. And then we do our division. And we were left with x squared plus x minus 6 as our quadratic factor. And if we were to factorize that, which we can, two numbers that multiply to give -6 and add to give 1, that's +3 and -2. That means that we can write our equation here as y equals x plus 1, x minus 2, x plus 3. It also means then that our x-intercepts are at -1, 2, and -3. Okay. All right, so it's a sketch here. As long as we've got some level of accuracy with our scaling, we've got our x-axis here, we've got our y-intercept down here. We know that we're going to cross through our x-axis at -1, and -3, and +2. It's a positive cubic, which means it goes up through 3, down through -1, through -6, and then up again through 2. And that's all we need to do here. Okay, next one. What we've got with this one's a little bit different. Okay, this one's already factored, which is useful. But you'll notice here that we've got this squared business. Okay, now, again, it's a positive cubic because our leading term, x cubed, will be +1 x cubed. So it's going to be shaped like that. Our y-intercept, when x equals 0, we've got 0 times -1, which will be 0. So that's our y-intercept. Our x-intercepts, rather, when y equals 0, we'll end up with x squared times x minus 1 equals 0. Using the null factor law, we have x equaling 0 or x equaling 1. And there's only two intercepts here. And with this one here being squared, that means that this result that we have here is what's called a double zero or a double root. Okay, so, and whenever that happens, that means we have a turning point on the x-intercept here. Okay, so x-intercept at 1 and at 0 shaped like that, and the y-intercept is at 0 as well, the actual curve of a graph is going to look like that. Okay, so it has a turning point on the x-axis. Wherever there's a double zero, wherever there's a double root, I don't mean 0 here because this is 0. A 0 is an x-intercept. Okay, double 0. All right, so whenever you have that double root, or where there's this something squared, then you've got the turning point on the x-axis at that x-intercept. Okay, and that's our graph. All right, the next one we've got here, y equals this result here. So this one's already factored. Now, if we have a look closely, the reason that this one's highlighted is that what we've got, first of all, our leading term, when we expand it, will be negative x cubed. So it's a negative cubic, which means it's shaped like that. Starts high and finishes low. Our y-intercept, we have a look. When we let x equal 0, y will equal negative times negative 1 times, that becomes 0, that's 0, and we're left with 5. So that's 5. Now, x-intercepts, when y equals 0, are going to be negative x minus 1 x squared plus 4x plus 5 equals 0. Now, null factor law, we can see that means x will equal 1. But this one here, normally if we had factorized and we had that, we'd see if we can factorize this. Now, we're looking for two numbers that multiply to give 5 and add to give 4. Well, it has to be multiplied to give positive 5, which is either positive 5 and positive 1, but add those and you'll get 6. Or if we multiply negative 5 and negative 1, we're going to get negative 6. So this can't be easily factorized, but it doesn't mean that it can't get an answer. But what we'll do is we check using the discriminant, b squared minus 4ac. b is 4, so we square that, minus 4 times 1 times 5, and we're left with 16 minus 20, which is negative 4. Now, because that's negative, there is no solution for this equaling 0. So that means there's no x-intercepts associated with that particular quadratic factor. So this here is a situation where there's only one x-intercept. Okay? One x-intercept means that the graph can look like that, or it's going to have this sort of thing where there's only this one point where it intersects the x-axis. So let's have a look at graphing this particular one. Okay, we know that it passes through the x-axis at 1, and we know also that it passes through the x-axis at 5, the y-axis at 5. So that means it's coming down here like that, which means that it's going to be curved something like that. Okay, and that's all that's necessary for this particular graph.